First chapter, second section, linear models and rates of change. We have 5 objectives in this section. The first objective, find the slope of a line passing through 2 points. Write the equation of a line with a given point and slope. Interpret slope as a ratio or as a rate in a real-life application. Sketch the graph of a linear equation in slope-intercept form. Write equation of lines that are parallel or perpendicular to a given line. The slope of a line. The slope of a non-vertical line is a measure of the number of units the line rises or falls vertically for each unit of horizontal change from left to right. Consider the 2 points x1, y1, x2, y2. So here, x1, y1, and x2, y2 on line. Okay, look at the definition. So slope is the measure of the number of units the line rises or falls. So this is a line, okay, rises vertically. So here, vertically. So how to get, so this vertical we call delta y. Okay, the delta y is given by y2 minus y1. So you can see the height here is actually you take the y2 minus the y1 of, okay, for each unit of horizontal. So here, horizontal. Change from left to right. So from left to right. So take the x2 minus x1. So we call delta x. As you move from left to right along this line, a vertical change of delta y equal to y2 minus y1. Okay, or you can say change in y units correspond to a horizontal change of delta x equal to x2 minus x1. You can say change in x units. Okay, the triangle here we call delta. And this symbol we call delta y and delta x. So the definition of the slope of a line. The slope m, we use symbol m of the non-vertical line passing through x1, y1 and x2, y2 is given by this formula. M equal to delta y over delta x. So where delta x equal to y2 minus y1. And delta x is x2 minus x1. And make sure x1 not equal to x2. And slope is not defined for vertical line. When using the formula for slope, so this is the formula for slope, you can use the alternative formula. y1 minus y2, x1 minus x2. They are equivalent. So it does not matter in which order you subtract as long as you are consistent. And both subtracted coordinates come from the same point. This figure shows 4 lines The first has a positive slope, and the second has zero slope. The third has negative slope, and the last one has undefined slope. Let's prove the first figure. You can take this point as the first point and this point as the second point. So you name the first point x1, y1. Okay, the first point. The second point x2, y2. Okay, so you can name the gradient of the first figure as first gradient. So the slope formula y2 minus y1. So will be 1 minus 0 equal to 3 minus negative 2. Okay, so you will get the answer 1 over 5. Okay, so here m1 equal to 1 over 5. In general, the greater the absolute value of the slope of a line, the steeper the line. Equation of line. Any 2 points on a non-vertical line can be used to calculate its slope. This can be verified from the similar triangle shown below. Okay, so now the gradient. Okay, how to calculate the gradient? So you can take the y2, this y2 star minus y1 star over the x2 star minus x1 star. Or you can take the y2 minus y1 divided by x2 minus x1. As long as these 4 points lie on the same line. If x1, y1 is a point on a non-vertical line that has a slope of m, and x, y is any other point on the line, then gradient can be written as y minus y1 over x minus x1. This equation in the variables x and y can be rewritten in the form y minus y1 equal to m x minus x1. So meaning that you take this equation, you multiply by x minus x1 at both sides, then you will obtain this equation. You will obtain this form. So which is called the point slope form of the equation of a line. So the point slope form of the equation of the line that passes through the point x1, y1 and has a slope of m is given by this formula. Okay, let's try the first example. Find an equation of the line that has a slope of 3 and passes through the point 1, negative 2. Then sketch the line. How you going to find the equation of line? Use point slope form. And after that, you just need to replace the y1 where given from the question. Y1, okay, the point you can see x1, y1. So the y1 is negative 2 and the x1 positive 1. And replace the gradient, the slope here, m by 3. Okay, then you simplify. Then lastly, you solve for y. So we obtain our equation of line. to sketch the line, first plot the point 1, -2. Then, because the slope is m equal to 3, you can use the slope definition. Then you locate a second point on the line by moving 1 unit to the right and 3 units outward. So here, the first point 1, -2. And how to locate the second point? Okay, based on the gradient. Because you know that the slope formula m equal to delta y over delta x. So since your m is equal to 3, so your delta y will be 3 and your delta x will be equal to 1. Okay, then from the first point, you move, okay, to the right 1 unit and move outward 3 units. Then after you get the second point, then you connect the first point and the second point. Then you form a straight line. Okay, and remind you again, to sketch the graph, you should have x-axis label, y-axis label, and equation name. Move on to the next objective. The slope of a line can be interpreted as either a ratio or a rate. If the x-axis and the y-axis have the same unit of measure, the slope has no unit and is a ratio. If the x and y-axis have different units of measure, the slope is a rate or rate of change, different. And this one, no unit and ratio, is for same unit. Take your time to understand this example. The maximum recommended slope of a wheelchair ramp is 1/12. So you see, the value here has no unit. A business installed a wheelchair ramp that rises to a height of 22 inches over a length of 24 feet. So we can refer to figure below, this figure. The length is 24 feet and the height is 22 inches. The question asks, is the ramp steeper than recommended? Firstly, you know the value given is a slope which has no unit. So you should know the horizontal and the vertical axis must have the same unit. Then the first step, you change the 24 feet into inches. So you multiply by 12, then you get 288 inches. So the slope of the ramp is the ratio. Okay, it's a ratio because it has no unit. So of its height to its length. Okay, so based on the slope formula, okay, you apply, okay, you substitute the value, and then you get the value is 0.076. Okay, then because the slope of the ramp is less than the given value 1/12, where the 1/12 is 0.083, so the ramp is not steeper than recommended. Okay, the slope is a ratio and has no unit. We try other example. The population of Colorado was about 4,302,000 in 2000 and about 5 million 29,000 in 2010. Find the average rate of change of the population over this 10-year period. And what will the population of Colorado be in 2020? Look at the solution here. Over this 10-year period, meaning that from 2000 to 2010, the average rate of change of the population was the change in population divided by change in years. You substitute in all the given value and you simplify, you will get 72,700 people per year. For the next question, you can assume that Colorado population continues to increase at this same rate for the next 10 years. So it will have a population of about 5,756,000. The rate of change found in previous example is an average rate of change. An average rate of change is always calculated over an interval. Next, objective. Many problems in analytic geometry can be classified in two basic categories. The first category, given a graph, what is its equation? Where this one we have covered in the previous objective. Given an equation, sketch its graph. Okay, so for line, problem in the first category can be solved by using the point-slot form. Okay, so the point-slot form, however, is not especially useful for solving problem in the second category. Okay, so we cannot use the point-slot form to solve the second category. We cannot sketch the graph based on this. Okay, point-slot form. Okay, but I know, okay, you can use, okay, the method that you have learned in the first section. Okay, where you contract table, okay, then you sketch the graph out. Okay, but we still have another way. So the form that is better suited to sketching the graph of a line is the slope-intercept form of the equation of a line. The graph of the linear equation y equal to mx plus b, and we can say this linear equation as slope-intercept form, whose slope is m and y-intercept is 0b. So recall back, okay, the first section, y-intercept on y-axis and the x-coordinate is 0. Look at this example. Sketch the graph of each equation. Look at the first, okay, the A. This equation, y equal to 2x plus 1. So you know the 1 is b. B is y-intercept, 0, 1. So you can see 0, 1. So this is the y-intercept, okay, the point here. And because the slope is m equal to 2, so based on y equal to mx plus b, m equal to 2. So you know the line rises because the slope is positive. Okay, and based on the slope definition, 2 is, okay, the 2 actually is a 2 over 1. So meaning that delta y equal to 2 and delta x is equal to 1. Then based on the point here, okay, our first point, you can treat this y-intercept as a first point, then you move horizontally, okay, 1 unit and move upward 2 units, then you get a second point, then you connect, then you form a straight line. Okay, x label, y label, and equation name, okay, must have. Get a second. So y equal to 2. So just only the 2, there's no gradient, so it's horizontal line. Y equal to 2. Okay, 2 is a b. y-intercept. So at this point, 0, 2. For the last equation, you can rewrite the given equation into slope-intercept form. Once you have obtained slope-intercept form, you can identify the y-intercept 0, 2 because b is 2 and the slope m negative 1 over 3. Okay, this means that the line falls 1 unit for every 3 units it moves to the right. So based on the point here, okay, 0, 2, okay, the y-intercept, okay, then you move horizontally 3 units and move downward for 1 unit. So you get this point, then you connect. Because the slope of a vertical line is not defined, its equation cannot be written in the slope-intercept form. However, the equation of any line can be written in the general form. Okay, so this is the general form where you move all the variable and the constant to left side and your right side is nothing. So we call general form. Okay, for example, this is a vertical line x equal to a, where a is a constant. So can be represented by the general form. You move the a to left side. So x minus a equal to 0. So we obtain general form. So this is a summary of equation of line. The last objective. The slope of a line is a convenient tool for determining whether two lines are parallel or perpendicular. We say these two lines are parallel because of the slope of the first line and the slope of the second line are same. And we say these two lines are perpendicular because of they satisfy the condition. M1 multiply M2 equal to negative 1. Okay, this is a summary. Two different non-vertical lines are parallel if and only if their slopes are equal. M1 equal to M2. Two non-vertical lines are perpendicular because they satisfy this condition. M1 equal to negative 1 over M2. Look at the last example. Find the general form of the equation of the line that are passed through the point 2, negative 1. So look at the, be careful with the key point. You must write your equation in the general form. And are parallel to the line 2x minus 3y equal to 5 and perpendicular to the line 2x minus 3y equal to 5. Okay, the same line. First, you need to write the given equation into the slope-intercept form. So you rearrange. Okay, then you obtain now the slope-intercept form. Okay, so from this slope-intercept form, you can identify the m. And you can refer to this diagram. So what is the question asking? So this is the given line. The gray color is the given line. Okay, 2x minus 3y equal to 5. Where this is the given line. Okay, so you need to get the other line that passes through this point. 2, negative 1, then must parallel to this given line. This is A part. Okay, this is A part. And for the B part, you need to get the line that passes through this point, 2, negative 1, and perpendicular to this given line. Okay, so this is a, okay, you can refer to this diagram, okay, for your, okay, and reference. And now the problem is, okay, how to obtain these two equations. Okay. Okay, so for the A part, so the line through 2, negative 1, okay, through this point, okay, then it's parallel to the given line, so meaning that also has the same slope 2 over 3. Okay, so you can base on the point slope form. Okay, you substitute in. Okay, just replace y1, x1, and m. Okay, then you simplify. Okay, you simplify. Okay, then you rearrange. Okay, so move all the constant and also the variable from your left, from your right to left side. Then you obtain, okay, the equation in general form. Okay, so for B part, using the negative reciprocal of the slope of the given line, you can determine that the slope of a line perpendicular to the given line is negative 3 over 2. Okay, so meaning that you can use the formula. Okay, so how to get the m2? So equal to the negative 1 over m1. Okay, you substitute in, then you will get your m2. Okay, so after you obtain your m2, okay, then the condition also same as, okay, the first one. Okay, the line must pass through the point. Okay, the same point. So you substitute in your x1 and y1. Okay, y1 and x1. Okay, here. Okay, y1, x1, and your m2. Okay, your gradient. Okay, you substitute in, then you simplify. Okay, then you expand. Okay, and you move, okay, all the variable and also the constant to left side. Okay, so you obtain general form.